Okay, we're going to look at solving now these problems from 6.1.13. We'll look at A. We see that this one is in slope-intercept because an isolated variable is equal to something else. It's not truly slope-intercept, but the point being that as long as x is isolated, we can substitute it in. That's why we're choosing substitution. So what I'll do is I'll take this equation, the second equation, and I will replace this x with 4 minus 2y. Then I'm going to work it through. I'll start by distributing. I'll get 12 minus 6y, and then we're outside the parentheses, minus 2 more y is equal to 4. I notice I can combine like terms here. I have negative 6y and negative 2y, so that'll be 12 minus 8y is equal to 4. And then I'll subtract 12 from both sides. When I subtract 12 from both sides, I'll have the negative 8y, so it'll be negative 8y is equal to 4 minus 12, which is negative 8. And then we'll divide by the negative 8, and we'll figure out what y is. Y will be equal to 1. Okay, now that I know that y is 1, I can replace y in one of these equations with 1. So I'll replace it in this first equation. I'd be allowed to use either one, but I'll use this one just because. Okay, and what that allows is for us to solve for x. So 2 times 1 is 2, so we can now say x is equal to 4 minus 2. Therefore, x equals 2. So our solution is x is 2, y is 1. The solution is 2, 1. I'll put all this in red to show that it is my work. And I'll check it in Desmos. We expect to get 2, 1 when we put this into Desmos. So let's see what actually happens in Desmos. And we get 2, 1. We got it right. Oh yeah. My solution is, in tribute to Daniel and Vincent from second period, fire! That is my solution for A. All right. B. The method chosen is elimination here because they're both in standard form. What I notice is that if I multiply one of these equations by negative 1, then I'll have a negative y to add to a positive y. So what I'll do is I'll take this equation here, and I'm going to solve it. By multiplying this by negative 1. So I'll make all that red to show that it's my work. And we get negative 3x minus y, because it distributes to everything, is equal to negative 1 times 1 is negative 1. We will then add this equation to the other equation with the understanding that what we're really trying to do is make the y's disappear. And the way we'll do that, of course, is that we will add the two together, knowing that having a negative coefficient to this y will make the whole thing cancel out. So negative 3x plus 4x would be 1x. And then the negative y and the positive y would just be plus 0. And that would be equal to negative 1 plus 2 is positive 1. So x equals 1. Alright, so now if x equals 1, I can plug it in over here to find out what y is. So it doesn't matter which one you choose. It does not matter which one you choose. So where I see the x, I replace with a 1. And therefore 3 times 1 plus y, so it's 3 plus y is equal to 1. I subtract 3 from both sides and I get y is equal to negative 2. So my solution is x equals 1, y equals negative 2, and I'm going to put this into Desmos to see if I have actually got this correct. So let's take a look here. and I get a solution of 1, -2, which is agreeing with what I've got. So my solution is, in this case, correct. Yes, good job. Feeling good about it. Okay, we'll do C and D in this video. Okay, C, x equals -5y plus 2. That looks like slope intercept. And then we have x equals 3y minus 2. Okay, so even though it's x instead of y being alone, we know that this isn't equal values because you have the same variable. In this case, x isolated, so you can make your new equation. So my new equation is going to be this expression is equal to this expression, because the two expressions are equal to each other, because they're both equal to x. So basically I'm substituting out the x value on both sides. Okay, now if that's true, first thing I'm going to do is I'm going to add 5y to both sides. So that's going to be 2 is equal to 8y, because I added 5y, minus 2. And then I'll add 2 to both sides, so I get 4 equals 8y. And then I'll divide by 8 to find what y is, and that will be 0.5, because it's 4 divided by 8, which is 1/2, is equal to y. Now I know that if y equals 0.5, I can plug it in right here to figure out what my x is. And of course I'm going to make everything red to show that it is my work. If you choose a different color, that's okay. Red is not, required. Alright, so then we're going to put 0.5 right here. Let's make this red. Why do we put 0.5 right there? Because we already know what y is. Okay, so then what is 3 times 0.5? It is 1.5. Okay, so we can rewrite as x is equal to 3 times 0.5, which is 1.5, minus 2. 1.5 minus 2, x is equal to negative 0.5. So what is our solution? Our solution is x is negative 0.5, y is 0.5, so it's negative 0.5, 0.5. Negative 0.5, comma 0.5. All right, let's take a look and see how we did. We're going to check it in Desmos to see if this works. And the important thing here is to get the right answer, but also to make sure that we're finding the best method. And so what do we find here? Negative 0.5, 0.5. We got it. Good. So by using equal values method here, did we get the most efficient solution? It felt pretty easy, so I'm going to say yeah, it was good. So it was correct. It was correct. And I can't spell correct. Isn't that ironic, right? Spelling correctly should be, that should be like fundamental, man. All right, D, last one we're going to do for this video. Here we have 2x minus 4y equals 10, and then 2y plus 6 equals x. It looks at first like they're both in standard, but then if you notice, actually x is isolated here. So that's why we said we're going to use substitution here. It's sort of substitution wearing a cheap disguise. It's pretending the x isn't alone, but it's alone right here, which means I'll take this, 2y plus 6, and I'll put it where I see x in this equation. So I'm going to substitute in this value for x wherever I see an x. Oops, like that. All right. So now, in order to find y, because we've eliminated the x's out, we need to work this through. So the first thing we'll do is we'll distribute. So that'll be 4y plus 2 times 6, which is 12, minus 4y is equal to 10. Somebody might have noticed something. Let us combine like terms. We have 4y and minus 4y. What does that make? That makes 0, yo. 0 plus 12 is equal to 10. That's just a false statement. That's not true. So what that tells us is that there's no solution to this thing. It can't be solved. What's that going to look like? When we try to graph these, what's it going to look like if it's no solution? Let's try to figure that out. Let's see. Anyone want to make a prediction? A no solution. What does a no solution look like when you graph it? I'm curious myself, actually. I'm wondering here. What's going to go on? As soon as I erase the semicolon, all the mystery will be gone. It looks like parallel lines. Of course. A solution is where they cross. So if they don't cross, if they're parallel, there's no solution. That makes a lot of sense. So my solution is, well, it's correct. I'm right. There is no solution. So my solution is correct. Why? Because there isn't one. Yeah. Very, very smart. Yeah.